electric vehicle system. In this system, I am going to discuss electric vehicle configuration, fixed and variable gearing, single and multiple motor drive. Now, coming to how electrical vehicle works. Electricity is transferred from a battery to a controller. The controller then sends the electricity to the electric motors when needed. The accelerator is connected to a variable switch which tells the controller how much power to send to the electric motors. The power output can vary from 0 to full as needed. The electric vehicles use an electric motor for traction and such things as chemical batteries, fuel cells, ultra capacitors and flywheels for energy resources. The electric vehicles has numerous advantages over conventional internal combustion engine vehicles such as reduced emissions, high efficiency, independence from the petroleum and smooth operation. The level of efficiency from tank to wheels is approximately 3 times greater than the electrical vehicles than for internal combustion engine vehicles. The reliable operation of batteries for electric vehicles requires an efficient battery management system. Two main factors decide the battery efficiency and affect its performance significantly, which are operating temperature and the rate at which the battery is charged and discharged. These factors determine the lifespan of a battery and hence battery lifespan can be prolonged when operating at a desired temperature. Based on this fact, many research works has been done in processing cooling temperatures to achieve a battery better operation under high temperatures. The main cooling techniques including air cooling, liquid cooling and phase change of material. The desired air cooling technique is considered the simple compared to the other cooling techniques. Heat is basically dissipated from the battery cells through a convection into the enclosure. This research studies the thermal behavior of the different electrical vehicles battery at a different rate of current charging and discharging. A comparative analysis of lithium battery cells used as a peak for an electric race car was performed for different brands from different manufacturers. This figure shows the primary configuration of an electric vehicle powertrain. The drivetrain in the work unit consists of three major subsystems: electric engine propulsion, energy supply, and auxiliary. The electrical propulsion subsystem comprises the electrical controller, power electronic converter, electric motor, mechanical transmission, and driving wheels. The energy source subsystem comprises the energy source, energy management unit, and energy fueling unit. The auxiliary subsystem comprises the steering unit, climate control unit, and auxiliary power supply unit. A conceptual illustration of the general electrical vehicle configuration is presented in this slide. In this figure, the blue arrows refer to the control links in the electrical vehicle system. The red arrows indicate the electric links, and the blank links indicate the mechanical interconnections. Batteries are one of the most regularly used technologies for energy storage, and the conversion of the electrical energy into portable chemical energy is not possible without batteries. The capacity to charge, that is, to store energy is using a chemical process, is achieved through a distinguished process like a reduction and oxidation reactions that can create electron transfers from different chemicals. Electrical energy can thus be released from the chemical energy during the battery discharge. These reactions takes place within the storage cells, which are combined into a single mechanical and electrical unit to create a fusible module. A group of modules is connected electrically to form a battery pack that contains a long charge or discharge time and low and high power energy density. Batteries are composed of one or more electrochemical cells. Battery cells are two types: liquid electrolyte and solid electrolyte, both of which contain positive and negative electrodes. When the battery is charged, it causes fundamental chemical reactions in the electrochemical cells that stores the energy. When the power is required, a reverse chemical reaction causes the battery to supply power. These are different sizes of batteries that range from less than 100 watts to multiple megawatts. The round trip efficiency of battery is estimated to be in the range of 60 to 80% depending on the type, climate time, cycle time, and the type of the electrochemistry applied. Generally, there are five types of batteries used in industrial and utility scale energy storage: lead acid, nickel cadmium, sodium sulfur, lithium ion, and sodium nickel chloride. For electrical vehicles, nickel ions are the most used type nowadays. Classification of electrical drives or types of electrical drives. The classification of electrical drives can be done depending upon the various components of the drive system. Now, according to the design, the drives can be classified into three types such as single motor drive, group motor drive, and multi motor drive. The single motor types are very basic type of drive which are mainly used to is in simple metal working, household applications, etc. Group electric drives are used in the modern industries because of various complexities. Multi-motor drives are used in heavy industries or where multiple motoring units are required, such as railway transport. The parts of the electrical drives, and here is these equipments are termed as a part of the drive system. Now, loads can be of various types, that is, they can have specific requirements and multiple conditions which are discussed. The first of all, we discussing about this other four parts of the electrical drives, that is motor, power modulator, source, and control unit. Electric motors of various types. The electric motors can be divided into four types: shunt wound DC motor, series wound DC motor, compound wound DC motor, and permanent magnet DC motor. AC motors are two types: induction motors and synchronous motors. Now, synchronous motors are of two types: round field and permanent magnet. Induction motors are also two types: squirrel cage induction motor besides and wound motor. Besides all of these, stepper motors and switched reluctance motors are also considered as a part of the drive system. So, there are various types of the electrical motors and they are used according to their specifications and uses. When the electrical drives were not so popular, induction and synchronous motors were usually implemented only where fixed or constant speed was only the requirements. For variable speed drive applications, DC motors were used. But as we know that induction motors of the same rating as a DC motors have various advantages, like they have lighter weight, lower cost, lower volume, and These less restrictions on maximum voltage, speed and power ratings. For these reasons, the induction motors are rapidly replaced by the DC motors. Moreover, the induction motors are mechanically stronger and requires less maintenance. When synchronous motors are considered, wound field and permanent magnet synchronous motors have high full load efficiency and power factor than the induction motors, but the size and cost of the synchronous motors are higher than the induction motors for the same rating. Brushless DC motors are similar to the permanent magnet synchronous motors. They are used for servo applications and nowadays used an efficient alternative to the DC servo motors because they does not have the disadvantage like commentation problem. Besides of these stepper motors are used for the position control and switched reluctance motors are used for speed control. Power modulators are the devices which later the nature of frequency as well as the changes the intensity of the power to control the electrical drives. Roughly, power modulators can be classified into three types: converters, variable impedance circuits, switching circuits. As the name suggests, converters are used to convert the current from one type to another type. Depending on the type of the function, and converters can be divided into five types. First one AC to DC converter, second one AC regulators, third one choppers or DC to DC converters, fourth one inverters, and fifth one is the cycle converters. AC to DC converters are used to obtain the fixed DC supply from AC supply to the fixed voltage. The very basic diagrams of the AC to DC converters like AC to DC converters. AC regulators are used to obtain the regulated AC voltage. Mainly auto transformers or tap changes transformers are used in these regulators. Coming to the AC to AC converter, choppers or DC to DC converters are used to get the variable DC power. Power transistors, IGBTs, GPOs, power MOSFETs are the mainly used for this purpose. Coming to the DC to DC converter, inverters are used to get the AC to DC. The operation is just opposite to that of an AC to DC converters. PWM semiconductors are used to invert the current. Coming to the DC to DC converter, cycloconverters are used to convert the fixed frequency and fixed voltage AC into the variable frequency and variable voltage AC. The thyristors are used in these converters to control the firing signals. Variable impedance circuits are used to controlling the speed by varying the resistances or impedance of the circuit, but these controlling methods are used in the low cost DC and AC drives. There are can be two types or more steps which can be controlled manually or automatically with the help of the contacts. To limit the starting current, inductors are used in AC motors. Switching circuits in motors and electrical drives are used for running the motor smoothly and they also protect the machine during the faults. These circuits are used for changing the quadrant of the operations during the running condition of the motor, and these circuits are implemented to operate the motor and drives according to the predetermined sequence to provide interlocking to disconnect the motor from the main circuit during any abnormal conditions of the fault. Sources may be of single or three phase. 50 Hz AC supply is most common types of the electricity supplies for both the domestic and commercial uses. The synchronous motors which are fed 50 Hz frequency have maximum speed up to the 3000 rpm, and for getting higher speeds, higher frequency supply is needed. Motors of low and medium powers are fed from 400 volt supply and higher ratings like 3.3 kV, 6.6 kV or 11 kV etc. are provided. Control unit. Choice of the control units depends upon the type of the power modulator is used. These are of many types, like when semiconductor converters are used, then the control units consist of the firing circuits which employ linear devices and microprocessors. So this discussion provides us a simple concept about the several parts of the electrical drives here. Coming to the advantage of electrical drives, electrical drives are readily used these days for controlling the purpose, but this is not the only the advantage of electrical drives. There are several other advantages. Are these drives are available in the wide range torque, speed, power. The control characteristics of these drives are flexible. According to the load requirements, these can be shaped to the steady state and dynamic characteristics, as well as speed control, electric braking, gearing, starting. Many things can be accomplished. The are adaptable to any type of the operating conditions, no matter how much vigorous or rough it is. They can operate in all the four quadrant of the speed torque plane, which is not applicable for other prime movers. They do not pollute the environment. They do not need refilling or preheating. They can be started instantly and can be loaded immediately. They are powered by the electrical energy, which is atmosphere friendly and cheap source of the power. Main components of electrical drives. The difficulty of the classification of electrical drives is caused by the fact that the drive systems are dedicated to the specific motor types. Here, an overview is given about the trends of the electrical drive systems based on some fundamental features. One classification point of view is how many motors are operated for one drive. There are one and multiple axle electronic drives. In this video, the one axle drives are explained. The main components of electrical drive system can be shown in this slide. The thick arrows denoting the way of energy flow. Depending on the actual applications, there may be a two-way energy flow at the load side. The electromagnetic motors are also capable of the two-way energy flow, but the power electronic devices, that is not only always possible, especially for the older types. So in this power electronics, there are four different converters types can be distinguished. First one, DC to DC converter, DC chopper. AC to AC converter, inverter. Third one, AC DC converter, rectifier. Fourth one, AC converter, AC choppers. Thyristor based cyclo converters, transistor, matrix converters. The simple drives, the power is usually supplied from a AC electrical network, and therefore only the last two types of the converters, AC to DC and AC to AC, would be enough. An example for that can be found in the lower quality drives, which are using thyristors, just like a few transistors. In this slide, the one-way arrows are symbolizing the mostly one-way energy flow. In case of AC motors, because of the reactive power developing in the windings, even in the motor mode, the two-way energy flow is required. Primarily for DC drives, it is an important classification point of view that in which quadrant of the rotational speed torque plane can be electrical drive operate the DC motor. Coming to this particular slide here, and this is the interpretation of the four quadrants. The four quadrants are determined by the direction of the supply voltage and current. Supposing an external excited DC motor led by an armature voltage, be the armature current and be the induced voltage of armature winding. The signs of the current and voltages in the quadrants of the figure can be shown in this slide. Now in this motoring mode, the directions of the voltage and currents are the same. The motor is consuming the power from the electrical network. Electrical energy is converted to the mechanical energy. The motoring mode need to be for rotating of the motor forward and backward can be found in the current first mode and second quadrants. If for some reasons of the directions of the current changes, then in any case the sign of the generated torque will also change. If the directions of the voltage and current are on the opposite of each other, then the electrical network will take up power. Mechanical energy is converted into electrical energy. This is called regenerating brake mode and can be realized in the first quadrant and fourth quadrants. It is important to note that a DC motor can enter in the second and fourth quadrants such a way that the directions of the voltage and currents are remaining the same motoring mode, but the direction of the motor rotation is changed through an external constraints. The asynchronous motors are also capable of this mode, but synchronous motors are not. In the second and fourth quadrants, mechanical energy is converted to the electrical energy in any case. However, in case of the directions of the voltage and current are the same, then the motor will consume the power from the electrical network as well. In other words, both the electronic mechanical energy will be converted to heat. This means a negative impact for the electrical energy of the drive. Resistor should be inserted into the electrical circuit of the rotor output of the motor, on which the generated heat can be dissipated and limit the current of the motor in case of the synchronous asynchronous AC and DC motors. This mode was necessary in case of the crane or elevator when the load is lowered in the past, because there were no cheap electronics available with the generating mode at any rotational speeds. The generating mode can be achieved only at the high speeds than the no load speed. In case of the DC supplied motor, electronic control is needed for the manipulation of the energy supply voltage. In 4-quadrant servo drives, lowering of the weights is done in the generating mode regardless of the motor type. The generating mode is ensured by the electronics. The directions of the energy flow in the three-phase system, three directions modes can be shown in this particular slide. In this particular slide, the direction of the energy flow in the different modes in this particular slide here. The rotational speed of an asynchronous motor supplied through an AC chopper can be changed in a very limited extent. These systems won't be discussed in this particular video, but here is 4-quadrant servo drives. First of all is noted that when even for determining the AC drives, direct AC to AC converters can be used. In this particular, instead of the using AC chopper, transistor matrix converter should be used. This solution is not adapted for the industry, but it can be happened. That is, the solution will provide industrial optimal. And most of the servo drives are operated in all 4 quadrants, and the conversion is done in 2 steps. First, the main voltage is rectified, so will form an internal DC circuit. Then, with the use of the AC chopper in case of the DC motor, or with an inverter with chargeable frequency in case of the AC motor, the given motor will be supplied. And coming to the layout of these two servo drives here, there is only one way arrow pointing out from the electrical network box, because nowadays this is typical. The most common and cheapest rectifiers are based on the diodes, and these units cannot feed energy back into the electrical network. The brake resistor is used for the dissipating the energy feedback from the motor. In case of the diode based rectifier, the non sinusoidal power supply means a more significant problem that can one way energy flows because of these devices are taking up non-sinusoidal current and causing pollution to the electrical network. In many cases, the diode-based rectifier is kept in the system, but an electrical filter is inserted between the electrical network and the rectifier to minimize the electrical pollution. The sinusoidal current consumption can be achieved with the open loop controlled rectifier. These devices are enabling the two-way energy flow and also acting as a filter. The solution is not common nowadays, but in the near future, it is possible for the industry to adopt the technology. Only the voltage or current can be forced to the motor, the other one will be developed as a result. Thus, there are voltage and current source power supplies. The voltage source supply easier to realize, but the current source supply has more direct relationship between with the torque, thus the making the direct torque control motor simpler. In the 80s of the and the 90s were actually industrial applications using so-called current source transformer, current source inverter drive topologies. Nowadays, voltage source inverter drive topologies are dominant. This has technological reasons, but no one knows in which direction the technology will further develop in the future. Also, in the 80s and 90s, the so-called resonant converters and in the connection, the so-called soft switching have appeared. Most of the motors can be operated in the fourth quadrant mode. The torque of the synchronous motors can be positive and negative in both the rotating directions and extend into the two quarters. In the former case of the motors is in the motoring mode. In the latter case, the motoring is in generating mode. The external excited DC motor and a asynchronous motor can enter in the three quadrants at the same voltage directions.